Assessment Task 3, Part B, Question B. So this is a loan question, and the question says, through working out of the first three periods, consider a home loan of $500,000 to be repaid over 20 years with an interest rate of 9% per annum compounded monthly. So we're going to be working out the first three periods first using this formula up here, A equals P, open bracket 1 plus R, close bracket to the power of N. So we need to determine our values first before we do that. So A is what we're trying to find out, the balance. So we're using this equation. P is our principal. So in the question, it was 500,000, which is how much the home loan is. R is our ratio, or our interest rate, which is 9% per annum. But because it's being compounded monthly, we need to divide it by 12 because there are 12 months in a year, which gives us 0.75%, which written as a decimal is 0.0075. N is our number of periods, which is 20 years, but because it's being repaid, since the repayments are monthly, we need to times that by 12 to give us 240, so we convert the years into months. So period 1, the question also says to define Bn as the balance owing after n periods and M as the monthly repayments. So Bn is going to be our periods and M is going to be our repayments. So we put our values into the formula. So we've got B1, which is our A, what we're trying to find out. 500,000, which is our principal. Open bracket 1 plus 0.0075, which is our ratio or our interest rate. Close bracket minus M. And when it's simplified, 500,000, open bracket 1.0075, close bracket minus M. Now what's happening here is our home loan is getting interest on it for the first period, and then we're minusing our repayment. In our second period, we're now going to sub B1 in, put interest on that, so 1.0075 close bracket, and minus our repayment again. So this chunk here is going to be our B1, and then from here we add interest onto it, minus our repayment. So what's happening here is this interest here is being multiplied by the 500,000 times 1.0075, and it's also being multiplied by our previous repayment, and then we got our next repayment on the end. So when expanded out, it becomes 500,000 open bracket 1.0075 squared, close bracket squared, sorry, M open bracket 1.0075 close bracket minus M. Third period, we can start to see a pattern happening, but we need a third period to establish it. We again sub in B2, interest on it, minus repayment. So this chunk here is our B2, here is our interest again, minus our repayment. Now again, this interest here is being multiplied by 500,000, open bracket 1.0075, close bracket squared. It's also being multiplied by minus M, open bracket 1.0075 close bracket, and it's also being multiplied by our next repayment, by our previous repayment. So when expanded out, we get 500,000 open bracket 1.0075 close bracket cubed minus M, open bracket 1.0075 close bracket squared minus M, 1.0075 close bracket minus M. So now we've established our pattern through the first three periods. We're now going to move on to our first part, which is I, which says calculate the repayment. So our repayment is M. So now we need to determine M. And to do that, we skip to our last period, 240, using the pattern we've established. So the pattern we've established is the powers. So it will be 500,000 open bracket 1.0075 close bracket to the power of 240, which is this value here, and then so on minus m 1.0075 close bracket 239. Keep going all the way to 1 minus m. Now what we're going to do is we're going to put it into a geometric sequence. So, and because we're going to be taking things to the other side to determine m, we're going to make b 240 equals 0, and then to put it into a geometric series, we have 500,000 open bracket 1.0075 close bracket to the power of 240 minus m, and then inside this chunky we have our geometric series. And the reason it starts at 230 to 1.0075 to the power of 239 is because we're factorizing m because m is being multiplied by all of these, so all the way down to 0, actually, to the power of 0. So we factorize minus m out and place all of these into one chunk, and m is not being multiplied by the 1.0075 to the power of 240, which is why it's not included. So inside here we have 1.0075 to the power of 239 all the way down to plus 1. Now plus 1 is our first term, and the reason for that is because up here we have minus m. Now for minus m to be included, we need to have an invisible 1.0075 close bracket to the power of 0 in order for it to still remain. So once you do that, to the power of 0 equals 1, which is why 1 is our first term. Now we're going to take this part here, minus m, and then our geometric sequence, take it over to the other side, and when we take it to the other side, we have to add m, then our geometric series. So over this side will be m, then our geometric series, while this side will cancel out. So it would be this chunk here equals 500,000 open bracket 1.0075 close bracket to the power of 240. Now, because we just need m, we need to take the geometric series back to the other side. So we're going, since these two are multiplying, we now need to divide. So once we divide, this will cancel out, and it will be just on this side here, which is what we have here. Now we need to work out a geometric series to find m first. So using Sn, this formula here, Sn equals a open bracket r power n minus 1 close bracket all over r minus 1. We can determine our new values for that equation. A is our first term, which is equal to 1. R is our ratio, which is 1.0075. N is our terms, number of terms, which is 240. So we put that into the equation. S240 equals 1 open bracket 1.0075 to the power of 240 minus 1 close bracket all over 1.0075 minus 1, and we get 667.8868699. Now it's still not finished. We need to put it back under what we had before, because we only worked out the geometric series. So we still have the top part being divided by what we've just found out. So it becomes 500,000 open bracket 1.0075 close bracket to the power of 240 all over what we just found out, 667.8868699, which gives us our m, which is our repayment, 4,498.63. Therefore, monthly repayments are $4,498.63.